Today we're going to talk about quadratics with complex roots. So essentially what this means is we're going to be revisiting the quadratic formula, which we've already seen in Unit 1A. But we're going to be talking about what happens when the b squared minus 4ac portion ends up being a negative number. We already know a little bit about this. We know that if it does end up being negative under the radical, it means we have two imaginary solutions. But how do we actually write the answers for those? So please have your quad formula available close to you, and we'll get started. This one here is already set equal to 0, and we already have the order correct. So on your formula sheet, once again, we want to reiterate the squared term goes first, the term with just the variable goes second, and the term with just the number goes at the back. So this is A, this is B, and this is C. And we always want to make sure it's set equal to 0 before we label. So we're going to go ahead and plug into the quadratic formula. So x equals negative 1b, so negative 1 times 12 plus or minus the square root of b squared, 12 squared, minus 4 times negative 11, or a, times c, negative 7. So making sure we're using our formula and we plug that in right. We also want to put it all over 2a. So that goes all over 2a. Good news is you don't have to memorize this formula like I did. And then 2 times a, 2 times negative 11. If you want to use PEMDAS to solve this problem, go ahead and reference my previous videos where I showed how to do that. For the purposes of this one, I'm going to go ahead and use my calculator for this whole portion. This portion and this portion to make my life just a little bit easier. So negative 1 times 12 is negative 12. I like to do the top and bottom first because they're easier. 2 times negative 11 is negative 22. If you didn't have a calculator and you were doing PEMDAS, you would square this, multiply these together, and then combine my terms. You can see that in a previous video that I've recorded about quadratic formula. But I'm going to go ahead and plug in finding my discriminant. So 12 squared minus 4 times negative 11 times negative 7. This gets us a negative 164. So we talked about this yesterday or whenever we covered the last lesson or whenever you watched that video, that if this is negative, we know that it automatically has two imaginary solutions, which is something pretty much mathematicians made up because we knew we couldn't take the square root of a negative. It just wasn't possible. So when this happens, even if that number has a square root, well, we can check at the end. But even if it has square root, we want to start with first saying, okay, this is impossible. We cannot take the square root of a negative. So mathematicians made up a little trick that we can make it a positive. So we're going to make this positive. And then we put the letter I, which stands for imaginary, either on the outside of the radical, or you can put it right here before the radical. So our answer is technically x equals negative 12 plus or minus the square root of 164 with a little I. And I usually don't have my students go further. At Ivy Tech, they might teach you additional steps to simplify this radical. You might remember factor trees. I don't personally do that in this class. So if you want more information on that, let me know. We're going to check to make sure that 164 doesn't have a square root though by hitting second x squared. Since it comes out a decimal, we're going to stop here with our answer. Sometimes it does have a square root, so you can take it a step further, but really the only new piece of information here is making it positive if you get a negative under the radical and inserting that I in. That tells people, hey, like I made this positive because this problem was impossible to do. And I put this I to symbolize that they are imaginary solutions or made up, like an imaginary friend. So let's do the second one. I'll add this 4 over, and there is a like term. So -3 plus 4 is +1 equals 0. This is actually a really good one to do because it doesn't have a linear term. And by linear term, I mean it doesn't have anything with x. It just has stuff with x squared. So we can actually rewrite this as 12x squared plus 0x plus 1 equals 0. So we have our A, our B, and our C. And we can plug it in to our quad formula. So quad formula is -1 times B, which is 0, plus or minus the square root of B squared, 0 squared, minus 4 times A, which is 12, times C, which is 1, all over 2 times A, which is 12. Once again, I'm just plugging in the numbers. So if you haven't watched my other videos first on quad formula, you might want to reiterate back to those, but you're only plugging in the numbers. We're going to do this, this, and this. So we have enough space, hopefully, to solve our problem. So I know that this cancels, so I can put 0 if I want, or I can just put plus or minus. I'm going to do this part in my calculator. But first, 2 times 12 is pretty easy, and that's 24. So I like to do the easier stuff first. So I could do PEMDAS, but I'm going to go ahead and do 0 squared. I'm just going to do this in my calculator. Minus 4 times 12, see, times -1. Oh, that's a +1. If that happens, just go here and hit delete. There we go. That comes out -48. We got another negative answer right here. I have a feeling most of these are going to be negative or 2 imaginary solutions. Since it's asking you to actually solve the equation, you don't have to put 2 imaginary, and you don't have to find the discriminant like we did yesterday. So to clarify the difference between those, when it asks you to solve, you want to use this one. And when it asks you to find the discriminant, you want to use this one. So since it's negative, we'll go ahead and make it positive because we know it's imaginary. We'll put an I. Does 48 have a square root? Let's check it out. It does not. So we can stop our answer here. I've had people ask me if they can reduce this. No, because the 48 is stuck under the radical, so you have to stay there. Now, if you had, Mr. George, he might have taught you how to break down underneath a radical and make a factor tree, or how to take out the perfect squares, and then you can reduce. That would be for like, if you are taking the test to go into IB Tech, just let me know. We can go further with this. But for today, this is where I usually have to stop. Okay. So this one here is a good one because it doesn't have a B. So it's already set equal to 0, and you have an A and you have C because you have a constant. But you could rewrite this with a 0K in the middle. Just a little reminder that whenever there's not a linear term, because it should be ax squared, bx, and c, you want to insert that in. So here we have A, B, and C. And then we can plug it into our quad formula. So -1 times B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. It's a lot of force. So just remembering that we're plugging in that 4 for A and for C into here. So that's why there's so many fours. So we are going to go ahead and work this out step by step. I know that this one's going to cancel. Really, I just have to work out some other stuff. That cancels. Technically 0 squared is just 0 too. So I have my square root sign. If you're doing PEMDAS, you could just multiply these three together, or even in your calculator. So -4 times 4 times 4, or you could even incorporate the 0 squared if that makes your life easier. And it's a lot of 4s. So just want to make sure we're using our signs appropriately. Cool. This is a good one to do because you should end up getting a -64 and then a +8 on the bottom. First things first, if it's negative, we know that you can't take the square root of it, so you got to make it positive and put an I here to symbolize that it's made up imaginary solution, imaginary friend, whatever you want to be. And then now that 64 is positive, you might know already the square root of 64 is 8, but you could also do that in your calculator, hitting second x squared and putting it in there. So we can go ahead and take the square root of this. So we know that for our final answer, x equals plus or minus 8i over 8, because the square root of 64 is 8. And since 8 divided by 8 is 1, we technically have a plus or minus 1i, which could also just be a plus or minus I. You can leave your answer like this. You could leave it with the 1 in front if you would rather. Or you could go ahead and write x equals I, x equals -I. I know it's super weird to have x equals another letter, and we're not used to that. But the main thing here is when it does have a square root, go ahead and take the square root of it and drop the I down with it. Then you can see if they divide. Sometimes you just got to leave it a fraction, but since it divides, that works out nicely. Okay. Over here, if we bring that 8n squared over, make it negative and put it with its like term, our 9 doesn't have a like term, so we're going to have to carve out a little bit of space. So these two are not going to add together because they're not like terms, but these two will. 11 minus 8 is 3, so 3n squared plus 10n, and that 9 will just have to go at the back. We have to get it equal to 0. So we have A, we have B, and we have C. And we're going to plug it into our quad formula. So once again, that's on your formula sheet, right where it says quadratic formula. Ooh, I can't see it. There it is. So -1 times 10 plus or minus 10 squared minus 4 times 3 times 9 all over 2 times 3. Ooh, we're doing a lot of quad formula today. That's why I like to do so much in my calculator, because once I plug it in, I just feel like I'm exhausted. So we're going to go ahead and take it step by step. So -1 times 10 is -10. And 2 times 3 is 6. So that works out nicely. This whole thing can be done in our calculator, or you can do PEMDAS with exponents and exponents first. So it's a +10, right? Either way, I'm going to put in parentheses -4 times A times C. We get a -8. Looks like there's a trend here that they're all negatives, which is good because we're working with imaginary or complex roots. So we're going to make that a positive, and we're going to put I outside the root or in front. 8 doesn't have a square root, so we can leave our answer like this. If you'd rather put the I out front of the radical, if that looks better for you, you can do that. You cannot reduce 10 and 6 because 10 is attached to this I on the top. Once again, if you wanted to break down perfect squares out of this 8 and then reduce it, you can. I'm not trying to add excess work or excess confusion for you guys, but please let me know if you want some help doing that and I can help you break it down. But this is going to stay here since the square root of 8, I believe, is a decimal. Remember, we're not dividing by 2, we're taking the square root. So what times what is 8? Ooh, I don't want to write that down. I don't know about you guys, but yeah. So just a little bit about how to work with complex roots. There's a practice sheet. So just know as you're working through these, unless Miss Amanda made a mistake, they mostly are going to turn out with a negative under the radical, and you'll just simply make them positive and put an I. If they reduce further, or if they have a square root, you can go further with them. Just let me know if you have any questions, and have a great rest of your day.